Right, we are focusing on a very important part of the curriculum called trigonometry. In the diagram below, T has coordinates x and 15 is a point in the Cartesian plane such that OT is 17 units. P has the coordinates -2 and A lies on OT. K is a point on the positive x-axis and TOK equals the angle theta. And we continue to analyze this question, but to analyze this question in detail as follows. Right, so we actually have a diagram here. And the diagram is the one that is shown. So let's just complete this diagram here. Right, in an attempt to complete this diagram, we proceed as follows. Right, so we have that this angle here is theta degrees. Moreover, there is a point here with coordinates -2a. And we have a point here with coordinates x and 15. Okay, good. We have Yolanda as well. Y, and this is a point K, and X, like so. And we have this situation, and O is the origin. And the examiner is asking the question here, is asking us to determine. Right, it's asking us to determine with the aid of the diagram the following. Right. So we have 5 points. Let's call it number one. Number one. Right, the value of x. The value of x. How do we find the value of x? Anyone, Tando? What do you think? How can we find the value of x? X is there. I need to confirm first. Are you able to see the screen?
Yes, I am able
Okay.
to see.
Okay, thank you so much. Thank you so much, Tando. Okay.
Okay, from what?
Yeah, from the diagram we have. Okay, because one way to learn is to be engaged, is to sort of get involved. Okay. What do you think now about this? What do you think is how can the value of x be obtained? What is the first step?
So from what I understand, I think we must write we must make it a right angle triangle.
We must do a construction.
Construct a right angle triangle.
Yes, so we do a construction to make it a right angled triangle like so. Okay, we're good. Such that at this point, we're able to see that this is our y, and our y equals 15, and this is our x. Okay, good. Then what do we do next? What do we do next? We want to find the value of x. We want to find this one, this coordinate, the first coordinate. But up to the
I
side,
think
we know that OT is 17 units. OT is how many units? OT is 17 units. Right, so we have OT, which is 17 units. Okay. Now, if OT is 17 units, then we proceed to use Pythagoras. Proceed to use Pythagoras theorem. So we know something that x squared plus y squared is r squared, and this is credit to Pythagoras. So that if we have the triangle that we have the x and the y is 15, the radius is 17. We have x squared, the y is 15, the radius is 17. 17 squared minus 15 squared is equal to what? Right, so this is exactly 64. So with x squared and 64, we apply the square root on the left, the square root on the right, and we put plus or minus. Meaning x is plus or minus, 64 here. Right, so we have a 64 here. Right, so that x is plus or minus 8. But we understand the position of the x on the diagram, that x is on this side and x is negative. And therefore, we conclude, therefore, that x is minus 8. The reason for that is that P is in quadrant 2, the second quadrant. So we found x. Here comes the next question. Here comes the next question. Number 2. We want to find the tangent of theta. How do we find the tangent of theta? Tando, how? How?
so we know that tangent is opposite over adjacent.
We know from SOHCAHTOA that the tangent is opposite of adjacent, so we use SOHCAHTOA. So the tangent is opposite of adjacent, so that we know, therefore, that at this point, the tangent of theta is the opposite over the adjacent, so it becomes y over x. Next, what do we do next? Right, so y over x. So y is 15 and x is minus 8. Good. So we have that y is 15 and x is minus 8. Okay, we look at the next question, please. Right, so the next question is number 3 or part 3. We want to continue to find the cosine of 180 degrees minus x. How do we do this one, Tando? Must get the numerical value of this, must get the number associated with this, the numerical value. How do we do it? Number 3, solution.
We must first get what the value of cos theta.
Yes, the value of the cosine. Right. So obviously we need to find the value of the cosine here. So how do we find the value of the cosine here? First, using reduction formulae, we reduce this. Okay. So reducing this now, cosine of 180 minus theta. In which quadrant is 180 minus theta? Discussed this some time back during the past weekend. In which quadrant is 180 minus theta? Using the cast.
Okay.
Okay. Let's remind each other. So we remember that we look at the cast diagram. And this one is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. This is cosine theta, all positive. Sine theta, tan theta. So if you're here, you have 180 minus theta. You're here, you have 180 degrees plus theta. Here you have 270 degrees plus theta. And you are here 360 degrees plus theta. Okay. Moreover, here if you're at 90, you want to go to 180, it becomes 90 degrees plus theta. Okay. And also if you're at 270, you want to go back, it's 270 degrees minus theta. If you're at 360, you want to go back to 270, it becomes 360 degrees reduced by some acute angle theta. Okay, now this is all good news, and it's our old friend called the cast diagram. We call this the cast diagram, but some people call it the cast rule. Okay, because it's sort of a rule of reduction, or we can call it the cast diagram. Okay, Tando, we are back. In which quadrant is 180 degrees minus theta? From the cast diagram. What do you think, Tando?
It is the second quadrant.
Well done, it's exactly in the second quadrant because this one is the first quadrant. And this is, if this one is the first quadrant, this one is the second quadrant, the third quadrant, and this one is the fourth. Okay, so at this point, if you have 180 minus theta, it is in the second quadrant in which the cosine is negative because only the sine is positive, so the cosine is negative. So now, what is all this here? What is this? What is cosine theta from the diagram, Tando? What is cosine theta from the diagram? There. Here is the angle theta there. What is cosine theta using SOHCAHTOA? Cosine theta.
Cosine
Yes,
theta.
cosine theta. Yes, please. Using SOHCAHTOA. So in other words, cosine theta, this is the angle theta. What do you think, Tando? I don't need to tell you the answers because I want you to learn a little bit with us, you know?
Okay, it is adjacent over hypotenuse.
Adjacent of
So,
hypotenuse. So yeah, so it is what? What is the side adjacent? What is the adjacent side?
so the adjacent side is the one which is closest to the angle.
Okay, so which one is it?
So it's going to be a -8. That is our adjacent side.
Oh, the adjacent side is -8, and the hypotenuse is what?
17.
17, so it's -8 out of 17.
Yes, sir.
Well done, okay? Because I'm trying to get your mind to work. -8 out of 17. And therefore, the result is what here? Just the answer. Okay, so next question, Tando. Here comes the next question. Right. The next question is question 4, part 4. Now we need to find the sine squared of theta. What is the sine squared of theta? What is the sine squared of theta? Okay, so now we
We
must go
should,
back to the diagram. Yeah, must go back to the diagram, right? And then now, if we go back to the diagram, what is sine theta from the diagram, Tando? Let's just go back. What is sine theta from this diagram, Tando?
it is 15 over 17.
It's exactly opposite of hypotenuse, which is 15 out of 17. Well done. So in other words, at this point, if we have sine squared theta, right, sine squared theta is exactly 15 out of what? 17 all squared. And therefore, the result here is 225 divided by 289. Okay, so this is the answer. Okay, next question. Right, let me put on the next question. Okay, the next question is the value of A. Solution. Solution. Okay, I want to find the value of A. Okay. Here is the diagram. What is the value of A, Tando, in this diagram? What is the first step in finding the value of A? What is the first step in finding the value of A?
Hmm. Say, I think we also use Pythagoras.
You can use Pythagoras, right?
Yes.
Okay. Okay. You're on point. That's okay. Right. But the easiest way is to use 10 theta because if you use 10 theta, because this line here is a line whose slope we know, so we can use 10 theta. And if you use 10 theta, because we know the slope of this line, the 10 theta is opposite of adjacent, so it is 15 over minus 8. That is the 10 theta, which is 15 over minus 8. But it is actually equal to what happens, for example, at a given point. So the angle theta can be found in two ways. Either you say opposite here of adjacent at this point, or you do it, you'll find the same size of the angle. So you can do it here, y over x, or you can do it here, y over x, but it is the same angle theta. So you need to think of this and make sure you understand it. So effectively, what we're saying is here, if you have the tangent of theta, okay, the tangent of theta, which is, if you look at that point, it is y over x. It is y over x, which is a over minus 2. Okay, but also, It is actually the opposite of the adjacent, using the bigger triangle like I demonstrated on the other side. Okay. So now what is this? Which means A over 2 is 15 over 8, negative, negative. Okay, so if you have this, you multiply. So multiply, this 2 is going to divide 8. What is 8 divided by 2? The 4. So which means, therefore, that A is 15 out of what? A is 15 out of 4. So it's one way to do this, but there are many other ways to do the question. Okay, the next question is this one. In the next case, we are attempting to simplify. Okay, now let's look at this one. Okay, this one here is when, so we need to simplify. Here's the question. Simplify without using a calculator. Right. Without using a calculator. So we have the sine of 120 degrees times the cosine of 210 degrees times the tangent of 315 degrees. And then you have the cosine of 27 degrees. Okay, so this is the case, and you divide everything by the trigonometric sine of 63 degrees times the cosine of 540 degrees. Right, what do we do here, Tando? What is the first step?
I feel like
What is the first step, Tando?
we should substitute with the actual values.
What are the actual values, Tando?
I know that sine 120 is root 3 over 2.
How do you know? Okay, I mean, you're right, but somehow, but how do you know? It is correct, but use the calculator. Did you use the calculator? Because the examiner is going to think you use the calculator. We're just putting the square root of 3 over 2. Where does it come from? From 120. From sine 120, then we have a square root. How? How?
Sir, what was the question?
But remember, I'm saying my point is, remember, we're not supposed to use calculators in doing this question. But you see, the minute you have 120 and suddenly you say the answer is this has a square root in it, the examiner might just think that you have cheated. You have used the calculator. So, and that would be very problematic. So what do you think? What are we supposed to do, Tando? Is the question too easy?
No, I'm still thinking.
All right. My point is that if you just give the square root of 3 out of 2, you're going to think that you use a calculator. They would have think that you use a calculator. You're still thinking, so I'm waiting. I'm waiting for Tando. Okay, so this is how we do it, Tando. There are a couple of ways, but now we advise students to perform reductions here as follows. Um, okay, we continue with this one. So this is going to be 180 degrees minus 60. 180 degrees plus 30. This one is the tangent of 360 degrees plus 45. This one is acute, 27 degrees. You can leave it as 27 degrees. Okay, so the bottom is the sine of 63 degrees. So the sine of 63 degrees, you can write it as right, this one can write it as 90 degrees minus 27 degrees. And this one is 360 degrees plus 180 degrees. So we continue. Right, so we continue. So okay, we continue. So in each quadrant is 180 minus 60, Tando. In each quadrant is 180 degrees minus 60 degrees.
It is the second quadrant.
And the sign is positive there, so this one is going to be positive, the sine of 60 degrees. 180 plus 30 is in each quadrant. One 180 plus 30. 180 plus 30 is in the third quadrant. In the third quadrant, only the 10 is positive, and therefore the cosine is negative. So negative, you copy cosine and the angle. Right, now we have here the tangent of 360 plus 45. In each quadrant is 360 plus 45, Tando. 360 plus is in the first quadrant. 360 plus is in the first quadrant where all trig functions are positive. So in the first quadrant where all trig functions are positive, so which means therefore this result is going to be positive, but You write the tangent and 45 degrees. So we continue. We continue. So this one is cosine 27 degrees. And this one, 90 minus. In each quadrant is 90 minus. In each quadrant is 90 minus.
The first.
The first, right? Okay, continue. Ninety minus is in the first quadrant where all functions are positive. So this one is going to be positive, but there's a co-function change. There's a co-function change at what? At 90, which is because it's sine, according to the COCO rule, you put a co on the sign, it becomes cosine. Becomes cosine 27 degrees times. Okay, this one is 360 plus in the first quadrant where all the functions are positive, and therefore it becomes positive 180 degrees, like this. Okay. Okay. We have that. Now let's continue. What do we get out of these, Tando? So we have the sine of 60 degrees. And then we have minus cosine 30. Tan 45. Cosine 27. Okay, let's look at the bottom. The bottom is cosine 27, cosine 180. Um, Cosine 180. Right, so we have cosine 180 here. Okay, so now let's check this. Sine 60. What is sine 60? Okay, you have the special triangles here. If this angle is 60, this one 30, 2 to the square root of 3, 1. Now, using SOHCAHTOA, the sine of 60. The sine of 60 is the opposite over the hypotenuse. Opposite of hypotenuse. 60 degrees, opposite of hypotenuse, which is the square root of 3 out of 2. Next, you have minus. Cosine of 30 degrees. Here is 30. Cosine 30 is adjacent of hypotenuse, which is square root of 3 out of 2. Okay, now the tangent of 45 is a 1. Okay. So, okay, let's analyze here. The negative cancels out here. Negative and divided by negative, it's plus. And then you have square root of 3, which is 3 out of 4. You have that. You have that exactly. Let's see now. Let's see here. Okay, this one is minus. Watch out, this one is minus. Okay, because 315 is 360 minus 45. So 360 minus 45 is in which quadrant? Okay, it's in the fourth quadrant, and therefore it's minus. Tangent of 45 degrees. Okay, just watch that. 315 is 360 minus 45, so you have a minus there. So this one is minus, and therefore you're going to have a minus there, minus 1. Minus tangent 45 is minus 1. Okay, therefore the result here is negative. The result here is negative 3 out of 4. Next question. Okay, proof. That was question. Okay, it was this one here. Okay, it's not important to number the questions, but here's one question that says proof. Proof that if you have 1 over cosine theta divided by 1 plus sine theta. Okay, so we have this. How to prove this one? So to prove this one, you take one side and produce the other. So we shall let the left-hand side, left-hand side, which is 1 over cosine theta minus cosine theta over 1 plus sine theta. So which is this into 1 plus sine theta. So you have this divided by cosine theta, which is 1 plus sine times 1, 1 plus sine theta. So this divided by 1 plus sine is actually cosine times that, which is cosine squared. So you proceed now. Left-hand side. Okay, so if you look at these very carefully, we just have to simplify these, but simplify it very carefully. So let's just look at the fact that in the numerator, we have 1 plus sine minus cosine squared. 1 plus the sine of theta minus cosine squared theta divided by cosine theta into 1 plus sine theta. Okay, so left-hand side. So which means that you have 1 plus sine theta. What is cosine theta? in terms of sine theta, Tando? There's a Pythagorean relation. Sine squared theta plus cosine squared theta equals what, Tando?
1.
Good. Good. Yes, it is 1. So that if you have cosine squared theta is 1 minus sine squared theta. So that cosine squared theta is 1 minus sine squared theta divided by cosine theta into 1 plus sine theta. One plus that. So distribute here, which is divided by cosine theta into 1 plus sine theta. Okay, 1 minus 1 is 0. 1 minus 1 is 0, so that you have the sine of theta plus the sine squared theta divided by cosine theta into 1 plus the sine of theta. The left-hand side is the same as. So at the top, we have sine theta plus sine squared. Plus sine squared theta. In the denominator, we have cosine theta into 1 plus sine theta. Into 1 plus sine theta. Left-hand side. Common factor in the numerator. What is the common factor in the numerator, Tando?
It's sine theta.
Sine theta. We pull that one out and we have 1 plus sine theta. Cosine theta into 1 plus sine theta. What is the common factor in both the numerator and denominator, Tando?
1 plus sine theta.
And the result is the sine theta over cosine theta. And sine theta over cosine theta is equal to what? Is the tangent, which is the right-hand side. And hence, the left-hand side is the right-hand side. And thus, it is true that 1 over this cosine theta over 1 plus sine theta, which is the tangent of what? Of theta. Okay, here we need to determine the general solution of okay, which is 2 10x. Okay, need to determine how do we find the general solution, Tando? What is the general solution first and foremost? What kind of a solution is the general solution, Tando? How do we find the general solution of an equation? How? Because we have 3 sin x, which is 2 the tangent of x. 3 sin x, which is 2 sin x over cosine x. You cross multiply, which is 3 sin x cosine x equals 2 sine x. 3 sine x cosine x. 3 sine x cosine x equals, okay, because tan is sine over cosine. Do you agree? Okay, the tangent is the sine over the cosine. And now we cross multiply here. The cosine sits with the sine. So we have 3 sine cosine x equals 2 sine x. Right, so we have 3 sine x cosine x equals actually 2 sine x. Next, what do we do, Tando? Right. What is the next step, Tando? Here, what do we
I
do?
think we should take 2 sine x to the other side.
We take 2 sine x to the other side. Well done. Right, so we transpose 2 sine x across the equal sign. This is what we get. Then what is next? What is the next step?
Since we have like terms,
Since we have a common factor, the common factor is the sine of x, and if you put it out, we have 3 cosine x minus 2 equals 0. Next, what do we do? Next, what do we do, Tanda?
uh, do we
Okay, this
say
point
that
we equate to 0, which means sine x equals 0, or this one equals 0, and this means cosine x equals 2/3. Means sine x equals 0 or cosine x equals 2 out of 3. So what is the next thing that we can do here, Tando? We need to solve. How do we solve this?
we have, I think we have to substitute with the answers that we got to
We
the
need to get what we
original
call
equation.
reference angles. We need to get reference angles. So the reference angle is what? Is arc sine 0. Or here we get the reference angle, which is arc sine 2/3.
Uh,
Arc sine 2/3 reference angle. The reference angles are those angles that are reasonably smaller and often of acute size, acute angles. So this is like 48,19 degrees using a calculator. And here the reference angle is arc sine 0, and that would be 0. Right. So we have the reference angle, 0 degrees, or the reference angle. Okay, good. What do we do now? The sine function is 0 in multiple places. So it is 0 at 180 degrees. So it is 0 first at 0 degrees plus 360 times k. Okay, we add the multiples of 360 because we're dealing with what? We're dealing with the sine function whose period is 360. Okay, because remember that the equation is sine x equals 0, like this. So first and foremost, we're gonna say the reference angle plus multiples of 360, but also we can have the other one, 0, 90, 180, 270, 360. Okay, so it is 0 here, but it's also 0 here at 180, meaning here we have 180 degrees plus 360 degrees times k, where k is an element of integer of the set of integers. So the sign of 180 is 0, but the sign of 0 is also 0, but also the sign of 360 is 0. We include the fact that now here at this point, what we need to have is we need to uh, have x equals to 0 degrees plus 360 pi k, or 180 degrees plus 360 pi k. Okay, but we also come this side here. Okay, bearing in mind the equation we had, because we had cosine x, which was equal to 2 over 3. That's what we had. So if we get the solutions to this now, which means therefore we're gonna have what exactly? Okay, to get this one, you need to draw a diagram like this and remember your cast and look at where the cosine is positive. Where is it positive? The cosine is positive here in the first, but it's also positive here. So you're gonna find this angle here and call it x, but you're also gonna find the angle there, or you can also find and call it x. Or you can also find this angle there, like so. Okay, so it depends on the student. But now let's just find first this one. Okay, the 48,19. With 8,19 degrees plus 360 degrees times k, where k is an element of z. And then here now we have this one here that is in the fourth quadrant, because according to the cast rule, all are positive in the first, but also the cosine function is positive in the fourth quadrant. So we're going to say 360 degrees minus this. 360 minus will take us to the fourth quadrant. Minus the acute angle minus 48,19 plus 360 degrees times k, where k is in z. And as a consequence, what we're seeing here is that x is 360 minus 48,19 is exactly 311,81 degrees plus multiples of the period of the cosine. Remember, both functions, the sine and the cosine, have periods of 360, or have the period 360 degrees, and therefore we add integer multiples of that. Okay, so these are the answers there. But there is a way to also do this one. Or if you look at cosine x equals 2 over 3, so you can actually be in a position to see that at this point, x is arc cosine of 2 over 3 plus multiples of 360 degrees times k, where k is an integer. Because the cosine of negative theta is actually cosine theta, and the cosine of theta is cosine theta. So this one is going to be plus or minus 48. It's plus or minus 48,19 degrees plus 360 degrees times k, where k is an element of the set of what? Of integers. So this is the answer as well. Good. So we continue right now. We do more mathematics. Let's look at more math. Now we look at another set of questions. Let's look at another set of questions. Simplify this one. Right, and obviously the question is actually says simplify fully. Which is 90 degrees minus x, 180 degrees plus x, the tangent of x plus cosine x, x minus 180 degrees. Right, so
Right.
we do here,
Here.
Tando, how to simplify this one, Tando? How to simplify this? How to simplify this question, Tando? In which quadrant is 90 minus theta? 90 minus x?
It is the first quadrant.
It is in the first quadrant. Which functions, how many functions are positive in the first quadrant?
All of them, sir.
All of them. Well done. Right, so here, this one is 90 degrees minus x into cosine of 180 degrees plus x. Okay, this one is the tangent of x, and this one, okay, I'm just copying the question. So it's not that we are doing anything fancy, but I'm just replicating the question. And then we have here x minus 180 degrees. Okay, you have already said all of them are positive in the first quadrant. So at 90 degrees, is the cofunction change, so meaning the result is going to be positive. What is the cofunction of the sine function? Tando? What is the cofunction of the sine function? What is the cofunction of sine?
Cos, is it cos 90?
Please come again. So it becomes the cosine, okay? Because according to the co rule, if there's no co at 90 degrees, you put a co, and now it becomes cosine. X. In which quadrant is 180 plus x?
It is the third quadrant.
It is the third quadrant. And in the third quadrant, what happens? Which functions are positive and which ones are negative there?
Tangent is
Tangent is the one that is positive there, and
positive.
right, the rest are negative, meaning when I have negative and you copy cosine and x. Plus the tangent of x, cosine of x. In each quadrant is 180 minus, in each quadrant is x minus 180.
X minus 1.
Okay, this one is a negative angle. In each quadrant is x minus 180 degrees. Okay, I know you have not seen this before. That's fair enough. Okay, so I'm going to elaborate on this one. Just one sec. Okay, then the certain angles that are negative. So you start from 0 and then you have minus 90 degrees. You have minus 180 degrees. You have minus 270 degrees. You have minus 360 degrees. Okay, so these are the negative angles that are measured in a clockwise direction. So now if you or to then say x minus 180. So imagine x that is an acute angle very, very small, e.g. 20 degrees, so that you have 20 degrees minus 180 degrees, which is minus 160 degrees. So in the end, then you have actually minus 160 degrees. Okay, so this x minus 180 is in the third quadrant. In the third quadrant, which functions are positive again, Tando?
It's tangent.
The tangent to the sign is negative. Negative the sign of x. Negative the sign of x. Okay, then, okay, what do we do next after this? So you have this, then now the tangent is the sine x over cosine x. And then you have minus sine x. So this is minus cosine squared x. Therefore, this here is minus sine squared. What is the answer to this? How do we simplify this, Tando? What do we do here?
We factor out the negative.
We factor out the negative, correct? And we have cosine squared plus sine squared. Then what is the answer?
-1.
The answer is exactly a -1, and we are done. Okay, good. Let's look at the next question. Let's look at the next question with Pando. Right, the next question is very straightforward. Right, so now let's look at the next one. Okay, in the next case, we need to simplify. Okay, we need to prove. We need to prove without. Using a calculator. That if we have the sine of 315 degrees, the tangent of 210, the sine of 190 degrees, the cosine of 100 degrees, the sine of 120 degrees is minus the square root of 2 out of 3. Okay, let's prove this. Let's prove this. So, how do we prove this, Tando? We present a proof. Right, so to prove this one, we have the sine of, okay, to prove we take a side. Let's let's take the left-hand side, complicated one. And it's exactly the sine of 315 degrees. The tangent of 210 degrees. (190 degrees). 100 degrees. to 120 degrees. So this is the sine of 360. What is 360 is, the 315 rather, is 360 minus 45 degrees. And this one can be seen as the tangent of 180 degrees plus 30 degrees. So this one is the tangent of 180 degrees plus 30 degrees. What about sine 190? How do we reduce that one, Tando? Because we said 315, it's easy. It's 360 minus 45. And then 210 is 180 plus 30. Then what is 190? What is it, Tando? What about 190? How do you reduce 190? How do you reduce
Oh,
that, Tando?
180 plus 10.
Please come again. Like so. 180 degrees plus 10. What about 100? Cosine 100 degrees in the denominator. How do you reduce that one?
We say 90 plus 10.
90 plus 10. Well done, which is actually 90 plus 10 degrees. What about 120? How do you reduce that one, Tando? Sine 120.
90 plus 30.
Which is 90 degrees plus 30. It's correct. But I would prefer at this point, if you can choose, you choose 180 minus 60. The answer is going to be the same. You can do the other one. Okay. But now we prefer that you choose something that is not going to bring about some co-function changes, because in case you forget to change the co-function, then it will be problematic. 360 minus 45, in which quadrant is that one, Tandu?
It is the fourth.
The fourth. And the sign is what? It's negative there. 180 plus 30, in which quadrant is that one?
It is the third.
It is the third. And the tangent is what? Is it negative or positive there?
It is positive.
Positive, the tangent of 30. Now you have the sine of 180 plus 10. In which quadrant is that one, Tando?
It is going to be the third quadrant.
The third. And the sign is what? Is it negative or positive there?
It is negative.
Negative sine 10 degrees divided by, in the denominator now you have the cosine of 90 plus. In which quadrant is 90 plus, Tando?
It is the second quadrant.
The second quadrant. And the second quadrant, the cosine is negative, but there's a co-function change. What is the co-function of cosine theta? Or cosine?
We use the Coco rule.
We use the Coco rule, and the Coco rule says if there is a co in the word cosine, you do away with the co and you're left with what? With a sine of 10 degrees. And therefore this one here, but we've already said the cosine is negative, so it's going to be negative. It's going to be negative because the cosine is negative in which quadrant? In the second quadrant. In which quadrant is 180 minus?
It is the second quadrant.
And the sign is positive there, in which case, therefore, this is going to be just positive, the sine of 60 degrees. Right, so good. And therefore, this one cancels that. And so we have the left-hand side. And therefore, if you have the left-hand side, therefore, this cancels out and we have minus sine 45. And you have the tangent of 30 degrees. Divided by sine 60. Okay. Okay, what is sine 45? Okay, so, okay, there are certain things you call the special angles. So if you're dealing with 45 degrees, 45 degrees, square root of 2, 60, 30. Square root of 3, 2, 1. Okay. So now, yes, my dear. Yeah, okay. Tomorrow. Yeah, tomorrow, my dear. Okay, fine, thank you, my dear. Right. So here you have the sine of 45. So the sine of 45 here becomes the opposite over the hypotenuse, and therefore opposite of hypotenuse becomes what?
It becomes 1 over the root of
Yes,
2.
it becomes 1 out of the square root of 2. Right, and then here you have the tangent of 30. Tangent of 30 is what? SOHCAHTOA.
It is 1.
Yeah, so a tangent of 30. Tangent of 30 is what? Is opposite of adjacent. 30 degrees. Opposite 30 is 1 out of what?
Root, no, it is not. Yeah, it is root 3 over 2. Oh, sorry, sir.
Uh-huh.
It is 1 over root 3.
1 over the square root of 3. Well done. 1 over the square root of 3. What about sine 60? In the denominator, there's sine 60. What about sine 60?
It is going to become the square root of 3 over 2.
Well done. Is the square root of 3 out of 2. So these things now, what do we get out of these if we simplify this? So the left-hand side, okay, if you multiply this out, it's minus 1 over square root of 2, square root of 3, multiplied by 2 over the square root of 3. So, okay, you multiply by the reciprocal. Then what does it become then, Tando, at the end of this? What does it become then, Tando?
Okay, it becomes
You need to simplify that, right? So if you simplify that, what does it become, Tando?
still trying to simplify. Does it become 6? Also, say, does it become the square root of 3 over 2? Oh,
Okay, that's fine. Yeah, but we're trying to simplify these. Okay, you're on point there. Let's see what you're getting exactly out of this. Okay, so in the denominator, square root of 3 is 3. So now you can write minus 2 over,
uh,
yeah,
2 root 3.
please come again.
Or it's gonna be negative 2 over 2 root 3.
Negative 2 over square root of 3 by square root of 3.
It is 3.
Then what do we do? So the left-hand side is minus 2 over minus 2 over 3 square root of 2. What do we do now when you get here?
We should multiply by the reciprocal. Not the reciprocal. We should
What do we do, Tando, here?
we should multiply it by the denominator.
Yeah, multiply like this. So if you do that, you have minus 2 the square root of 2 in the numerator, and denominator square root of 2 by square root of 2 is what? It's 3 times 2. 2 cancels, which is minus the square root of 2 out of 3, which is the right-hand side. Because remember, we had to prove these things. We had to prove that this is minus the square root of 2 out of 3. And so went on to prove that this is square root of 2 out of 3. And the conclusion is that hence, the trigonometric sine of 315 degrees times the tangent of 210 degrees times the sine of 190 divided by the cosine of 100 degrees times the sine of 120 degrees. And this is minus the square root of 2 out of 3. Okay, and we're done. Let's look at the next question. Let's look at the next question. Okay, the next question says in the diagram below, R is a point in the first quadrant. Such that TOR is equal to alpha. RO is extended to P such that OP is equal to double RO and TOP is beta. It is given that the sine of alpha is 3 out of 5. And we have this here. The y-axis. And we have this one here is R, P, alpha, T, X, without using a calculator. Determine. Okay, if you look at part 1, the value of 10 alpha Okay, so obviously there are a couple of things, but you also know that the sine of alpha is 3 out of 5. But you also know that OP is 2RO. Determine the value of 10 alpha. Okay, what is the answer to this one, Tando? I'm giving you 2 minutes. 2 minutes. Hello, my dear. Hello, my dear. Oh, they went out. All right, let me know when your mom is back. All right, guys. Hello, my dear. Anyway, yeah, and thanks to found something. Okay, Tando, you got the answer. What is the answer?
So I am still using Pythagoras theorem.
You are still using
I
Pythagoras
constructed,
theorem. Yes.
yes,
Constructed.
I
Okay.
first constructed.
Okay, good. That's fine. Please go ahead and let me know what the answer is to the question. So if you use Pythagoras theorem like this, you'll be able to see this angle is right, and this is exactly opposite of a hypotenuse. Opposite of hypotenuse, and therefore we have x squared plus y squared equals r squared. According to this diagram, this is y and that is r. We just did x. R is 5 and y is 3. So we just need only x. We already know that y 3 and r is 5, which means x squared is 5 squared, 25 minus 9, and this is exactly x squared. What is 25 minus 9?
16.
16. So that now if you have x squared equals 16, you can apply the square root. So that x is plus or minus 4. But now here, it's only x equals 4. Which means for the point R, therefore, will have coordinates x and y. So x is 4 and y is 3. X is 4 and y is 3. X is 4 and y is 3. So that in the end, then you find the tangent of alpha, which is exactly y over x, which is, y is what here? X and y, so y is 3 and x is 4, and that is the answer. Okay. Next question. Okay, the next question is you need to find the value of the following. The value of sine beta. Let's look at the solution to this. So that now, what is sine beta now, Tando?
I'll say it is going to be 4 over 5.
How do you know?
I say firstly, because sine alpha is 3 over 5. And then
Okay, for obviously, if you see this one, beta is alpha plus 180. So if you take this alpha, and this is a straight line, 180 degrees, alpha plus 180 is beta. And that means here, to find the sine of beta, we must consider the fact that beta is alpha plus 180 degrees. Okay. In which quadrant is alpha plus 180? You can say 180 plus alpha. Same thing, but it's more popular to write here 180 degrees plus alpha. In which quadrant is 180 degrees plus alpha?
it is the third quadrant.
And the sign is negative. Okay, so what is then sine alpha now? Sine alpha. What is sine alpha? So the sine of alpha now becomes, according to SOHCAHTOA, the opposite over the hypotenuse. Opposite over hypotenuse. Opposite is 3, hypotenuse is 5. So it becomes minus 3 out of 5. Did you think that it was going to be minus 3 out of 5? Can't remember if you said that.
No, sir.
Okay, I'm trying to remember if you said something like that because you gave an answer, but trying to remember if it was anything close to that. Okay, but this is the answer. This is how it's done. Okay, because this is how we can connect beta and alpha. That is how we can connect angle beta and angle alpha. Okay, let's look at the next question. Okay, here, want to find the coordinates? The coordinates of P. The coordinates of P. Okay, let's look at the diagram. How do you find the coordinates of P? What do you think? What are the coordinates of P? Okay, so asking the question here, Tando, and we are saying we want to find the coordinates of P. How to find what are the coordinates of P here?
Coordinate P.
Yes.
Say, should we construct first?
Anything, but we want to find the coordinates of P.
I think we should construct.
I think we should construct.
Yes.
Okay, we can do that. Okay, but what do we know? We know that OP is equal to 2 what? 2 RO. Okay, if this is this one, so this OP is twice RO. RO is 5, and then this one is 2 times 5 is what? 10. Okay, so now this is what we get. So we can use anything we know. But we know this angle is alpha and this line is straight. And now if this is the case, the angles, the vertical opposite angles are the same, so that this angle is also alpha. So that at this point, then what we then have is we can use here opposite of hypotenuse for the sine, but you can also use opposite of hypotenuse there as well. Okay. Something of that sort. Okay, here we can use a sine of beta. So the sign of beta here, for example, if you want, you can use the sign of beta. So right now, if you use the sign of beta here, it is without even possibly going to the extent of putting this. The sign of beta here, we've already got it. Sine of beta is minus 3 out of 5. So we have that the sine of, we're looking at the solution here. What is the sine of beta? We have already got the sine of beta to be the same as what?
Negative 3 over 5.
Negative 3 out of 5. Okay, so if the sine of beta is negative 3 out of 5, we could also use what we know here, like this angle. So the sine of beta here is also opposite of hypotenuse, meaning it's also opposite of hypotenuse, which is y out of 10. Is just y out of 10 because, but this is still beta. So, okay, this is also y out of 10. So we cross multiply these things here, which is minus 3 by 10. Five y minus 30 over 5, which is minus 6. So if y is minus 6, then what is x? If y is minus 6, then what is x? Let's just look at the diagram. Y is minus 6 here. Y is minus 6 because minus 30 over 5. Minus 30 over 5 is minus 6. So that gives us y equals minus 6. So if y equals minus 6, okay, so we got that y is minus 6. Then what is x gonna become? You can use any of the things we know because you already know these things here.
We can use Pythagoras.
You can use Pythagoras, but looking at these triangles here, this one is 5, this one is double, which is 10. We've already got that y becomes 2 times 3, which is 6. So what is x gonna be? So it's just 2 times 2 times 2 times.
8.
So x is 4, so x is gonna be what?
8.
Minus 8,
Negative.
because it's on the negative side. Okay, but you can use Pythagoras as well. The answer is gonna be the same, okay? But we're able to see that x is actually minus 8 here. We're able to see that x is minus 8, and therefore x is minus 8 and y is minus 6. So this is xy. 5.4. So you need to prove here. Prove the identity. Sine theta minus 10 theta times cosine squared therefore, which is cosine theta minus 1 plus sine squared theta, which is 10 theta. How do you prove this one, Tando?
We let the left hand side.
We let to the left-hand side, right? So we're going to proceed. We're going to let the left-hand side be equal to sine theta minus 10 theta cosine squared theta cosine theta minus 1 plus sine squared theta. The left-hand side. What is the answer, please? What do we do here, Tato?
We So we know that negative plus sine. Wait, no. We know that 10 theta is equal to sine over cos.
Well done. We know that the tangent of theta is sine theta over cosine theta, but we also have this one, which is cosine squared, and we divide everything by cosine theta. Then next, what do we do with these things here? So this one here is 1 minus sine squared. 1 minus sine squared is what? So here, this cosine is going to cancel one of these. And this is a cosine divided by, what is 1 minus sine squared?
It is gonna be cos squared theta.
Good. So what is the next thing here? So we have sine theta is a common factor in the numerator, and this is 1 minus cosine theta all divided by, okay, there's cosine theta in the denominator, which is 1 minus cosine theta. So now these things cancel like this, and this is sine theta over cosine theta, which is 10 theta, which is the right-hand side. Okay, so this one then becomes 10 theta. This becomes 10 theta. So we continue. Because the question was that obviously we had to prove that this is 10 theta, and we've shown that it is exactly 10 theta. Here's another question. At this point, we need to determine the general solution for determine the general solution for the sine of x minus 30 degrees is equal to cosine of 2x. Let's look at this one and find the solution to this. How to find a general solution? We did an example. So what do we do now? How do we start here?
We use the Coco rules
We
for
use the
the
Coco rule. How do we
sign.
use the Coco rule now? Tando? I agree with you, you're right. So what we have here is we have the sine of x minus 30 degrees, which is equal to cosine 2x. Then what do we do next? So this is the sine of 90 degrees minus 2x. Okay, cosine 2x is the same as 90 minus 2x. The sine of 90 minus 2x. And what is the meaning of this then? Right. So at this point, you can write these as x minus 30 degrees is equal to, so when the sine of this equals the sine of that, it means that two angles are equal to each other, so that we have 90 degrees minus 2x plus 360 degrees times k, or x minus 30 degrees. And then now, obviously, because these two are equal to each other, but the 90 minus is in the first quadrant where everything is positive, or these are equal when we're in the first quadrant, but the sign is also positive in the second quadrant. And to say second quadrant, we say 180 minus this. 180 minus 290 degrees minus 2x plus 360 degrees times k, where k is an element of the set of integers. So which means that we have x minus 30, which is 90 degrees minus twice x plus 360 degrees times k, or we have seen that x minus 30 degrees is equal to 180 degrees. 180 is because 180 minus is because we're dealing with the second quadrant. The sign is positive in two quadrants. It's positive in the 90 minus quadrant, which is the first, but it's also positive, the sign in the 180 degrees minus into 90 degrees minus 2x plus 360 degrees by k, k in z. Okay, so you bring this across, which is 3x. Okay, 90 plus 30 is 120. Because the minus 30, you bring it across, it becomes plus 90, which is 120 plus 360. You divide by 3. What is 120 divided by 3? It is 40. 360 divided by 3 is 120 degrees by k. K, an element of the set of integers. You can put it at the end. Okay, so we also have x minus 30 degrees, which is 108 degrees minus 90 degrees plus 2x plus 360 degrees times k, k in z. Right, so you have the 2x here, you bring it across. X minus 2x becomes minus x. Now, 180 minus 90. 180 minus 90 is 90. 90 plus 30 is 120. Which is minus 360 degrees. Okay, so these are the answers. So then we have that x is exactly 40 degrees plus 120 by k, or x is minus 120 plus 360 degrees by k. And therefore, these are the solutions to these. Okay, that is the general solution to this question. We're to find the general solution to this question. And the general solution to this question is the one we just got. What is the general solution to this question? The general solution to this question is exactly 140 degrees plus 120 degrees by k. By k is an integer. Or you have the 120 here. Right, or we have the 120 here. Right, use white. Right, or you have 120 here. 120 degrees, like that. Okay, so we're done. Tando, you are at liberty to join us tomorrow at 4 p.m. when we're going to be doing more mathematics, okay? So you can join us tomorrow. We're going to be doing mathematics at 4 p.m. If you are free, 4 p.m. tomorrow, more math, okay?
Yes, sir.
Yeah, otherwise, thank you so much for joining us tonight. And I'm going to be sending the video in the next couple of minutes because this lesson is being recorded. So I'm just going to send the recording of our discussion today so that you can watch. Okay, when you watch this discussion, you need to take down notes. You need to have a book
Yes,
separate for us, and you take down notes. You write everything here that we do. So that these things you can have them, because if they're just on the video, then you'll forget some of them. But if they're in a book that is separate, not your school book, but our book, because we're here to do too many things in mathematics, too many things in science as well. Okay. Otherwise, thanks a lot, Tando. Right. If
okay,
you're free, yeah, if you're free tomorrow afternoon at 4 p.m., you can join us. Same link. But if you're busy, it's okay. So yeah, because you had your math today, but yeah, you can join us tomorrow if you're free, and we can continue with more mathematics. 4 p.m. Saturday afternoon tomorrow. Thanks, Tando. Goodbye, Tando.
okay. Thank you, sir.
Goodbye, Tando.
Okay, goodbye.
Mhm. Mhm.